Hi, this is Professor Gonzalez, and we're going to take a look at graphing the log functions in section 4.2. So this first function, this first problem asks us to begin by graphing log base 3 of x, and then use transformations to graph the given function. We need to also identify the vertical asymptote and determine the function's domain and range. So let's take a look at this function. It's 8 plus log base 3 of x. So whenever we're graphing a function, it's very helpful to have the idea of the basic function. So we're trying to graph f of x equals 8 plus log base 3 of x. So what does log base 3 of x look like? Some of the points that it's going to go through are when x is 1, log base 3 of 1 is equal to 0. That's one of the rules you have to remember. Log of any base of 1 is always going to be 0. And when x is 3, log base 3 of 3, that's 1. Again, that's one of our rules with log. So we're going to have the following 2 points. 1, 0, and 3, 1. So it's going to go through this point right here, and we'll just say that's the point 3, 1. So a log function skims along the y-axis, so it has a vertical asymptote here at x equals 0. And so this is the function we want to graph. So basically all that's happened here is that we're adding 8 to each of these values. So we're going to take this point 1, 0, and instead it's going to be up here at 1, 8. And the point 3, 1 is going to be up here at 3, 9. So the whole thing is just being kind of shifted upwards. So there's no change to our asymptote. So let's see how we can graph this in MyMathLab. So when we're graphing these in MyMathLab, you've got to use this click to enlarge the graph, and then you need to know which one of these is the log tool. So it's this one right here. This one that's going the other direction, that's an exponential. So we're going to grab the log tool and just sort of put it down, usually put it right there at 1, 0. And you can see that it already has the correct base. We just have to talk about the transformations. And this one has a very simple transformation. It has a vertical shift of 8. So we will hit enter, and there you go. That's this one. And then we also need to grab the line tool and add in the vertical asymptote, which is going to be there along the line x equals 0. And I think that it didn't go dashed, so we need to make sure that it's dashed. If it's not dashed, it will mark it wrong. Okay, I think that might have got it. Let's try it. Okay. Now it's asking for the vertical asymptote, which we just said was the line x equals 0. And now it's going to ask for the domain. And I think the easiest way to look at the domain is to look at the x values where the function's defined. And you can see here, we know for a log function that it's not defined at 0. Okay, and so we'd have an open parentheses on 0. And then it's defined for all x that are strictly greater than 0. So the domain's going to be 0 to infinity here. And the range, as you can see, is all real numbers. Okay, it's just all real numbers. We'll move on from that problem. Okay, take a look at the next problem. And it's another graphing problem. This one's log base 10, but we can see that 2 things are happening for the transformations. First of all, we have a negative log x. So that is going to be a flip over the x-axis. And then you can see that there's a 2 out in front, so that's going to shift the whole thing vertically too. So we'll go ahead and do it like we did before. We're going to take our log tool and just put it down in a basic location. We know that this is going to be reflected over the x-axis, so we'll flip it. And then it's going to go up 2, so a vertical shift of 2. Okay. So it's gone up 2. It hasn't gone to the left or right. So when we look for the asymptote, it's just going to be the same one we've had before. So it's going to be the line x equals 0 again. Okay. So that's how you graph with these. Okay, so also want to give a little bit of help here on the domains for these. So this particular problem, we're being asked to find the domain of log base 8 of x minus 5. So we'll take a look at this. So the thing you need to know about logs is if we have log base b of x, it's generally going to have this kind of a shape, right? It's going to go through the point 1, 0 and b 1. Actually, it looks more like this. I'll draw it just a little bit better here. So the standard points are going to be here at 1, 0 and at b 1. So logs generally look like this, with the asymptote that we've mentioned before, right here, x equals 0. And so the domain in general is going to be 0 to infinity. And so when we have one that's been transformed, like this one that we're looking at right here, we're going to look at basically where x minus 5 is strictly greater than 0. Okay, so the domain for this one is from 5 to infinity. And that's because if you think about what's happening, this function is being shifted right 5. So in other words, if I was going to add that to my graph, I'd be moving over here to 6 and 5 plus b, and the whole thing would just be going kind of over here, like that. Okay, and the asymptote comes along with it, and so the asymptote for this one is going to be x equals 5. So the domain for this function is 5 to infinity. Just like that. Okay, I hope these have helped you with these couple of problems here. And if you have any other questions, just please drop me an email.